In this lecture, we will be seeing about quicksort algorithm with an example. This quicksort is also known as partition exchange algorithm or partition exchange sort, wherein we use the main technique called divide and conquer for partitioning. Divide and conquer in the sense we will find a particular place wherein we need to divide that particular sub-array into two different subarrays. Okay, so here we will choose any element of an array as a key element or a pivot element. The pivot element can be either the first element of an array or the last element or the middle element or any random element from an array. So the partitioning is done in such a way that all the elements which are less than the pivot element or the key element will be put or placed into its left side partitions. That left partition subarray, it may not be sorted. Similarly, all elements greater than the pivot element are placed towards its right side in such a way that that is the right partition subarray need not be assorted. Similarly, if I have any value which is equal to the pivot element, it can be either moved on to the right or towards its left subpartitions. Finding out a proper place for a pivot element is called as a partitioning. So let's consider an example of an array A which has 10, 15, 1, 2, 9, 16 and 11. So we call this as the lower bound and this as an upper bound. And here in this example I have chosen a pivot element as the first element, that is A of 0, which is equal to 10. This as a pivot element. Now we have to find what is the position for this particular pivot element in this array of elements. So totally we have 7 elements. So we need to find out what is the position of 10 in this 7 elements. So we will have the elements when we find this position for this 10, the elements after that is towards this side will be greater than 10 and whatever the elements that have towards this side will be less than 10. So we have taken two variables called S and E. So what we do is we will compare the element at the starting, whatever that is, this is the starting value or S value. We will go on incrementing this S if the element is less than the pivot element. So we have chosen a pivot element as 10. So we will increment this variable 1 plus 1 when we find any value is less than or equal to pivot. Similar way, here we have taken end. E represents end variable here. So the funda is we will compare whatever the value from this side. Okay, so whatever the element is greater than pivot element, if any element is greater than the pivot element, what we do is we will decrement the E value. So S will be moving in this direction and E will be moving in this direction. And when we have array suppose when we are moving S variable, when we found any element is greater than the pivot, we will not increment the S, we will stop S here. Similar way, when we have any element less than the pivot, we will not decrement E, we will stop E. So we will continue this process when it violates the condition. And we will swap the starting and end value whenever the start has not crossed E. When the start, after where we go on incrementing and this goes on decrementing. So when we have not, this S have not crossed E, and when it violates the condition, and we will swap the values of S and E. Okay, and when it is crossed, when this S has crossed E, wherein E is somewhere, and when this S is being crossed, what we do is we will swap the pivot element with the end element. What we'll do, we'll swap the lower bound element with the end element wherever the end position points to. So we'll see this example keeping all these conditions in the mind. Okay, so first our starting value is S, that is here this first position lower bound, and our end value is the pointing to the upper position upper bound. Pivot we have taken as 10. Now our pivot value is 10, a of 10. So our starting value is here. Is 10 less than or equal to 10? Yes. So we will increment the value as s by 1. So s goes here. Now the condition is checked. Is 15 less than or equal to 10? No. So we will stop our s here. Similar way here from this we will check. So this E element will be compared with the pivot element. So our condition is pivot element should be less than this. So 11 greater than 10, that is 11 is greater than 10. Yes. So we decrement the value of E. So E moves here. Similarly, we will check 16 greater than 10. Yes. So we again decrement the point. E value by 1. Similarly, 9 greater than 10. Is 9 greater than 10? No. So we will stop E here and S has been stopped here at 15. So what we need to do here, it is status less than E. That is here the value. So S has not crossed E. S is less than E. So what we do was we will swap this 15 and 9. The rest of the elements keeps unchanged. So we will swap this 15 and 9. Okay. Now our pointer, S pointer is at this position and E pointer is in this position. Okay. So now our pivot element is same as 10. So we have to check whether 9 is less than or equal to 10. Yes, we will increment by s by 1. So now 1 is less than or equal to 10. Yes, what we do? We increment the s pointer. Is 2 less than or equal to 10? Yes, we increment the s pointer. Is 15 less than or equal to 10? No, we stop the pointer here. That is, we stop incrementing the value of s here. Now again we check the end value. Already we have the end pointer here in this position, right? So at this particular index. So E. So we will check 15 greater than 10. Yes. So we decrement E. Similarly, is 2 greater than 10? No. So now E pointer will be pointing towards the second, where the second value is placed. Now what we do, this S is moved over here and E is, this S has crossed the current E is now here. Now S has crossed E. So what we do, we have to swap the lower bound value with the value at the end place. So we have swapped the lower bound value and the value at this end position. So we will swap 10 and 2. So when this condition, when S is being crossed S, we have arrived at a position to place the pivot element in its correct position. So here we need to partition. So when this start has crossed your end, so we need to have a partition now. So means this pivot element has found its correct position. So we have 10 here. We can see here whatever the elements greater than 10 will be towards its right. Whatever the elements value less than 10 will be towards its left. So now we have to partition these two. So this is one partition we call, this is the other partition. Same procedure we have to apply for this subpartition Pn1. Now this becomes our lower bound, this becomes our upper bound. This is, we have to call our quicksort algorithm recursively. So changing our lower bound and upper bound. So here suppose we call this as a location. So from what is the recursive function? From lower bound to this location minus 1. So to this partition, this is our location, right? So this becomes our location. This starting point will be location plus 1 towards our upper bound. Okay, so we will call the quicksort algorithm recursively in such a way that for this partition also this quicksort applies and this partition also the quicksort applies. So now here we have this becomes our starting and this becomes our end position. This is our lower bound and this is our upper bound. These elements are not in a sorted way. So now we have chosen this again as a pivot element. The starting element is a pivot element 2. So here it is greater, that is S, and here we have E. Is 2 less than or equal to 2? Same process of quicksort. So 2 less than or equal to 2? Yes. We increment S. 9 less than or equal to 2? This is 2. Is 9 less than or equal to 2? No. So what we do? We stop the pointer here. So here we will check 1 greater than 2? No. So this pointer, this E is not decrementing. So we have S here, E. So what we do, start has not crossed E, so we will swap the starting value and the end value. So we will have 2, 1, 9. We have swapped the starting value. This is, so here what is the value at the start? It is 9, and end pointer, this is 1. Now we have 2, 1, 9 in this array. It is not as gone to partition because it is not crossed. So it is not going to partition this array. Now we will have S here and we will have 9 here. This is the starting is again still our pivot is 2, right? So is 1 less than or equal to 2? Yes. So the starting will move over here. Is 9 greater than 2? Yes. So here E is being decremented towards the side, S is incremented, this S has crossed E. So when S has crossed E, what we need to do is we have to swap our lower bound and the end. So we will swap the lower bound and end. The 2 has found its position. So we will partition this. So this is our partition. Whatever the elements greater than 2 will be this side. Whatever the elements less than 2 will be this side. So since we have only one element left, we need not do any partition. Here also we have only one element. So we will not do any partition or subpartition for this. If we have more number of elements this side and this side, we will again partition this subarray and we will again partition this subarray. Since we have left with one element, there is no need for the partition. 2 has now found its position over here. So I told you like we have quicksort being applied at 2 different places, right? So this is one partition also the quicksort calls recursively. Here also the quicksort calls recursively. Similar way, so we have 15 and 16 and 11 in the second partition. So our starting point, this, if this is our location, this will be location plus 1. Okay. So starting element is 15. So I am taking this as the first element as the pivot element. So pivot is 15. So now we check 15 is less than or equal to 15. Yes. So we move this point. Similarly 16 less than or equal to 15. No. So here we will have the starting of the point. Now E. So 11 greater than or equal to 15. No. So the E pointer is here. So S and E we have to swap. So we will swap S and E. We have swapped 16 and 11. Now again we will, so we have swapped 11 and 16. We will have this S here and E over here. So we will check is 11 less than or equal to 15. Yes. So S will be moving towards this side and 16 greater than 15. Yes. E will move here. So now we have crossed, this S has crossed E. So when this has crossed E, we will have the swapping of the lower bound with the end. What is our lower bound? 15. So where is the E pointer pointing to? Here. So 11 and 15 gets swapped. So now 15 has find its position here. So when 15 has find its position here, we will, whatever the elements towards this will be less and whatever the element towards its right will be greater. So we have only one element this side and one element this side. If we have more elements, we will again partition this subarray. If we have more elements here, we will again partition this subarray. So we will see implementation of this quicksort. So partition. We have the array lower bound and upper bound. First element we have taken as the pivot element and we have two variables start and end. So we have to carry out the process when start is less than end. Okay. So when we'll check the start element is less than or equal to pivot. Whenever this side we have less than or equal to pivot element, we will increment the start, right? So when we have greater than the pivot element, A of end element greater than pivot, we do decrement the end. So we will check whether start is less than end. If that is the case, we will swap the start and end. If not, what we did, we will swap the lower bound and the end value and we will return the end process. This is our partition. After partition, we have to apply the quicksort. So quicksort, the array we pass lower bound and upper bound. If lower bound is less than the upper bound, what we do? Location, that is whatever the partition, we get one location, right? So that location we will move it, and so lower bound to location minus 1, that is one partition, and location 1 plus 1 towards its upper bound. So again we will call this quicksort algorithm recursively.